we are going to spend most of this triad talking about square roots and squares and their relationships with each other. And we already covered this in the opener, but somebody refresh me. Finish this sentence here. The square root of a number is the number that what? To get, multiplies by itself to get what? It's kind of tricky without knowing some terminology here. So before we answer this, I'm going to give you some terms. I want you to write these down. So square root looks like this. So we've got the square root itself, and then we're going to have a number inside of the square root. Somebody pick a number for the inside of our square root. 15. Let's make it one that we can take the square root of.
15.
4. All right. So we've got the square root of 4. This number inside of the square root right here, that is called the radicand. And I want you to make a square root on your paper and write that down just like I did. In the top right corner of your paper, you've got plenty of space for it. So the number inside of the square root is called the radicand. Okay, so now that we know that, I think we can finish this sentence a little bit better. The square root of a number, the square root of 4, is the number that multiplies by itself to get the radicand. Okay, so it's the number that multiplies by itself to get the radicand. So, for example, the square root of 4 is going to be what? It's going to be 2 because, how do we know it's 2?
2 times 2 is 4.
2 times 2 is 4, exactly. So 2 multiplies by itself, by 2, to get the radicand, which is 4. So 2 times 2 is 4. Okay? Another way of saying this, multiplies by itself. What's another way of saying multiply by itself? So another way of saying 2 times 2 is 2 squared, right? So another way of saying multiplies by itself is a number that you square to get the radicand. So it's two slightly different ways of writing the same thing. You can write either one down, and we're going to kind of look at it both ways, but we're actually going to look at it as a square more often than as multiplying by itself. So the number that you square to get the radicand is the square root of that number. There are only certain numbers that we can take square roots of. The numbers that we can take the square root of and get a whole number answer are called perfect squares. Okay, somebody give me an example of a number that we can take a square root of. 25 would be an example of it. So 25 we can take the square root of because it's 5 times 5, or 5 squared. What's another one?
16.
16 is another one that we could take the square root of because it's 4 times 4, right? What's another one?
9.
I heard 9. What's another one? 100 is one. Okay, what's another one?
81.
81 is another one. Okay, what's another one?
72. Oh, wait, wrong. 64.
64 is one. Okay, what's another one?
49.
49 is one. What's another one?
36.
36. I need to squeeze that in there. Okay, what's another one? 4 is one, yeah. So 4 is a perfect square. What's another one?
1.
1 is a perfect square because 1 is 1 times 1, right? So this, actually, you guys made a list here for me. Had them a little out of order, but I tried to get them in order here. These are all perfect squares. Okay, they're called perfect squares because we can get these by squaring a number. So 1 is 1 squared. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. Then we have 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, Can we do 11 squared?
No.
Why not? We could, couldn't we? Anybody know what 11 squared is? 11 times 11? 121, yeah. And then 12 squared would be 144, and 13 squared is 169, and we could keep going. You can square any number, right?
Yeah.
So these numbers right here that you get when you square them, those are called what? What are these numbers right here called? I'll give you a hint. It's at the top of the page here. Perfect squares. We want to list the first 12 perfect squares in our notes here. So we've got 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25, 36, 49, 64, 81, 100. That's the first 10, but we need 2 more. What's 11 squared? 121. And what's 12 squared? 144. And we'll stop there, but we could keep going, right? So every one of these numbers that I have written in the dark green here, we could take the square root of those, and we would get a whole number answer. Now in our opener, we tried to take the square root of 50. 50 is not on our list here, right?
Is that example 1?
Nope. 50 is not on our list here, right? So can we take the square root of 50 and get a whole number? No. So if we try to take the square root of 50, we're going to get a decimal. But we do know that it's close to 49, so the square root of 50 would be close to 7. So here's our first example. Don't write the answer down yet, because there's going to be a little bit of work that we're going to ask you to show why the square root of the number, in this case, why the square root of 64 is what? What is the square root of 64? 8. So we know the answer is 8, but we're going to show a little bit of work to show why the square root of 64 is 8. So go ahead and write the problem down. And so to find the square root, we're looking for a number that multiplies by itself or that we square to get 64, right? You guys agree with that? So we're trying to find a number that we square to get 64. So what we're going to do is we're going to rewrite the problem, and instead of 64 on the inside, we're going to put a square. What number do we square to get 64? 8. So instead of writing 64, we're going to write 8 squared. So we just rewrite the problem. It means the exact same thing, because 64 is the same thing as 8 squared. But now that we have it written like that, we have a square in there. Okay, so our goal when we're evaluating a square root is to first get a square inside the square root. Okay, now this square root right here, just by definition, tells us what the answer is. What number do we square to get that square root? 8. So then our answer is going to be 8. And what's happening here is that the square root and the square do what? They cancel each other out. It's just like adding and subtracting cancel each other out. So if you take a number and you add 3 and then you subtract 3, you get back to where you started. Well, here, if we take a number and we square it, and then we take the square root, we get back to where we started. Okay, so squares and square roots cancel each other out. They're opposites or inverses, just like adding and subtracting are, just like multiplying and dividing are. And that's going to be useful to us later on when we start solving equations that have square roots in them. For now, this is all you need to do. We are going to ask you on your worksheets, on your quiz, on anything that you do, to show this work. Okay, this is going to be worth points because this is showing that you understand exactly what a square root means. All right, same thing here. We all know what the square root of 4 is, right? We just said it a few minutes ago. But we need to show some work to show why the square root of 4 is what it is. So instead of putting 4 in the square root as the radicand, we're going to put 2 squared. Okay, so 4 is the same thing as 2 squared. And now the square and the square root can cancel each other out. You don't have to do this, but it's not a bad idea too. So this line here is just showing that the square root's gone and the square is gone. And that leaves us with 2. So since 2 squared is 4, the square root of 4 is 2. Okay, so 144. It's a good thing we put this on our list, right? What do we square to get 144? What?
12.
12. So 144 is the same thing as 12 squared. So again, we're just taking our radicand, 144, and we're rewriting it as a square. All right, so 144 is the same thing as 12 squared. We still have our square root there, but now the square and the square root are going to cancel each other out. So that's going to give us what? 12. All right, so we have the square root of 1. We want to rewrite the radicand so that it is a square. So what number do we multiply by itself, or what number do we square to get 1? 1. So this is going to be 1 squared. And so the square root and the square cancel each other out, and that leaves 1. So the square root of 1 is 1. It's kind of fun, right? Doesn't happen very often. In fact, there's only 2 numbers that when you take the square root of the number, you get the same thing you started with. Anybody know what the other one is? 0, yeah. Because 0 squared, or 0 times 0 is 0. So if we take the square root of 0, we get 0. Oh, this is an easy one, right? Why is this one easier than the other ones? Yeah, the radicand's already a square. So we don't have to do as much work on this one. All we have to do is cancel out the square and the square root, and we get 5. Now, if we wanted to, we could do this. We could say this is the same thing as the square root of 25, and then go from there, but that's just going backwards, right? How about something like this? This looks kind of crazy, doesn't it? Anybody think they know what might happen for something like this? Travion? On the inside? It would be. You don't have to do that, but it would be. So let's do this first. Let's use our calculators to help us out with it, and then we'll figure out a way to do it without the calculator. So this is the long way. So I'm going to write this down below here. This is the same thing as the square root of 5 squared is what? 25. And 7 squared is 49. So it's the same thing as the square root of 25 times 49. And 25 times 49, don't know that off the top of my head. So punch that in your calculator and you get the square root of 1225, right? Okay. And then, if you want to know what the square root of that is, your calculator can do it for you. So you put 1225 on the screen and you hit the square root button and it gives you 35. And that is the correct answer. That's a long way to do it. I think now that we have the answer, somebody might be able to tell me the shortcut. Look at the problem, look at the answer, and think about how you might be able to get from this right here to this right here. We could have just multiplied 5 times 7 to get 35. All right, so why does that work? Libby? Yeah, so the square root right here, the big square root, is going to cancel with this square and it's going to cancel with this square. It's going to cancel both of them out. So when we cancel out the square root, it's going to cancel both squares. Okay, now there's not really a good way to show it because it looks like we're canceling the square root twice, but this square root gets rid of both squares. So all that's left then is 5 times 7. And 5 times 7 is 35. Not only is that way quicker, but we didn't even need a calculator for that one, did we? Okay, this way, I don't really see any way around it. We're going to have to use a calculator to do 25 times 49, unless you want to do it by stacking them and multiplying them out. But then to get the square root of 1,225, that one you're probably going to need a calculator for. So not only is this way quicker by canceling the square root with both of the squares, but you don't need a calculator. Okay, you guys know what 5 times 7 is, right? Okay, done.